Everybody, Mrs. Bianchi. A track coach creates an obstacle course for his team. The coach plots the locations of three obstacles on the coordinate plane shown below. So we have obstacle A, obstacle B, and obstacle C. Each unit on the coordinate plane represents 3 yards. A student starts at obstacle A, then runs south to obstacle B, then runs west to obstacle C. What is the total distance in yards the student runs to get from obstacle A to obstacle C? So, in other words, they want to know if we're going to go from obstacle A to B, we need to figure out that distance, and then we have to figure out the distance from obstacle B to obstacle C, and then add the two distances together. Now, what's really important to understand is the fact that we know that one of these, so I'll just trace it over here, that's 3 yards. So we can count in multiples of 3. That's a strategy as we're doing the distance. But we can also just calculate how many units it is and then multiply it by 3 after. All right, so let's explore the idea of just counting the units. So let's start with the red line. If we figure out how far these 2 points are from each other, points A and B, and we just count how many units and then multiply by 3, that's an option. So we have 1, 2, 3, 4, 5, 6, 7 units apart from each other. Now, I do want to remind you that in class, we talked about another way if you can remember these rules or understand them. So we're going to come back to this, but we know that that's 7 units. So if it's 7 units and we take the 7 units and we multiply that by 3 because we have 3 yards in each unit, then we know that we're going to get 21 yards going this way. All right, so if we count the green, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 times 3 would be 30. So here we have 30 yards. Now remember, they want to know the total distance to get from A to C. So that means that you would have to add these two numbers to get your final answer in yards. Now I do want to talk about another method that you could have used. Now you could have counted by threes. You could have done 3, 6, 9, etc. and counted that way. But let's talk about using this approach. So this is point A. And if we wanted to figure out the distance between points A and B, we could look at the rules here. Are the points in the same quadrant? And they're not, right? This is in quadrant 1. This is in quadrant 4. So that would be a no. So we have to find the coordinates that don't match. So which ones don't match? These match, these don't match. So the ones that don't match, you're going to find the absolute value of both of those coordinates. So the absolute value of a 5 would be 5. The absolute value of a -2 would be 2. And we would add the absolute values. And if we add 5 plus 2, we get 7. So it's not an accident when we counted that out, we got 7 doing it that way also. So 7 units. So 7 units between A and B. Now, what about between B and C? So let's look at that. Let me erase this so we don't get confused. If we were to use these rules to calculate the distance between points B and C, again, we would say to ourselves, they're not in the same quadrant. So when they're not in the same quadrant, we first find the ordered pairs that these are the same. So these are the two that differ from each other. And we would add the absolute values of that. So we have the absolute value of a 3 would be 3. And the absolute value of a -7 would be 7. And if we add 3 plus 7, we get 10. Now we already got that, right? We got that using just simple counting. So in the end here, you could use the same approach. So remember, we got 7 here. We got the 10 here, but we'd have to remember that we have to multiply by 3 to get the yards, multiply this by 3 to get the yards, and you could have done it that way, and you would have added these two separate values to get the total yards. That would have worked just fine. So when you don't have a coordinate plane offered, sometimes knowing the rules, these rules right here, can be very helpful.